Okay, then start. Achha, you told me that it's about 8th of October, right?
28th October.
28th October.
Uh,
Yeah,
yeah,
that's
the
too
first
late.
exam is science.
Okay, so 2 chapters are coming now.
Yeah.
Chalo, ठीक है, then it's fine. Well, Gianna, what about your exam? Are they over?
No,
Gianna, what?
sir.
No, no. Okay, okay. What happened, Gianna? You have an issue with the camera?
Mm, yeah, sir. Just a minute.
अच्छा 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 ठीक है कोई बात नहीं करते ठीक है ये आया व्हाट अबाउट योर एग्जाम
Sir, they finished.
they finished have you got the marks
No.
no okay. Galvin have you got the marks Harshit what about your exam
Sir, they're over.
they are over have you got the marks from the school
No,
चलो ठीक है once you get the marks please share these basically marks and along with the answer sheet of yours ठीक है on the official number
yes.
okay?
Yes.
And we'll arrange a separate discussion for the exam discussion chalo that's great okay so yeah it seems like nobody's joining so okay ठीक है okay now in this class we are going to start the electricity chapter ठीक है first of all tell me uh, okay now the basic thing that we are going to discuss is the electric charges because electric charge is a fundamental quantity is the fundamental thing that is related to the electricity chapter because if there is no electric charge no electricity will be there because ultimately electric charge is like the atom and if the is the atom of the electricity so suppose that we are made up of multiple like trillions and like atoms our body is made up of very small atoms now. Everything that is there in the universe is made up of atoms right so that's why similarly electricity is made electricity is produced by the electric charges now we are in this class we are going to discuss the properties of electric charges and how do we differentiate between them, what are the properties and all, right? So that's great. Next, what happened, Ayat? Your video is flickering.
Is it still flickering?
Oh, no, it's clear. No, it's clear. Okay. So in this class, we are going to discuss the types of charges first. How many types of charges are there? Yes, everyone. How many types of charges are there?
2.
Harshit said two. What about you? Rest of you? Maha, Gianna, Galvin, Ayan.
2.
2 positive and negative.
Galvin, Gianna.
2.
Yeah. Gianna. I can share. Okay. Chalo, कोई बात Yes, there are two types of charges. First one is positive and another one is negative. And positive charge is called proton and the negative charge is called electron. Right? So this is the thing that you must have studied in the ninth standard in the chapters atoms and molecules. Right? So these were because okay. So next thing is positive charge or that is proton. There are two types of charge. First one is positive. And one more thing, this chapter is going to be a little bit longer than the previous chapter because electricity like basically involves numerous types of numericals and every numerical is a little bit different from the previous one. So it's a request to all of you, please do not miss the classes. And if you miss the class due to some emergency, so you have to watch the recording before joining the next class. Okay? Positive. And the B and the positive charge, it is called proton in the normal word positive charge and the B part is your negative. That is nothing but your electron. Okay, so this is the thing. Now let's understand the basic properties of charges. Like what are the things that are required to understand the charges? So basically, first thing that is there. So opposite charges repel each other. This is the basic, oh, sorry, attract each other, not repel. This is the basic property of the charges. Opposite means if the sign of the charges are opposite, like one is positive, one other one is negative. So there are two types of charges, and if you basically place both the two charges, so that they will basically attract each other. Okay, sure, that's great. And first, let's write the same charges for one, and I'll explain why. Same charges repel each other. Okay, same charges repel each other. Why? Let me tell you how. Suppose that this is a positive charge. So this is the explanation. Basically, this topic, the explanation that I'm going to give you is a little bit related to 12th class, but it is not a topic that is basically not understandable by you. So it's a very simple topic, right? So this involves the electric field. Electric field means that if the charge is there, so there will be a field around it. Suppose that you must have, suppose that there is a heater in the room. So what you will observe, you will experience some heat in the room, right? So it means that there is some heat area is generated due to the heater when it is on, and it is switched on, right? Everyone, yes or no? So electric heater, normally heater, okay? So similarly, charge is also a kind of thing that is basically produced, it basically placed in a room, is placed in a specific in like the universe. So there will be some kind of area in which electric field will be experienced. Electric field means that it will either attract or repel depending on the charge. Okay. So electric field is basically for the positive charge is outward. It means that it goes outwards like this. Okay. So as you can see this thing, this is like, so this will give you the complete insight why the same charge is repel and why the you can say the opposite charges attract. Okay. Just a minute, let me draw this. Copy कर लेता हूँ. Okay. So see this. Okay, so as you can see this thing that this arrow is going in this direction, this arrow is going in this direction. It means that there will be a conflict because they are in opposite direction. They will say, so it means so this will oppose the electric field will basically say to this charge that please go in this side, and this charge electric field will say please go on this side. So they are basically not in the same direction; they are in opposite direction. It means that they are repelling each other. Clear, everyone? Ayan,
Sir,
Galvin,
but both are positive, right?
the both are positive, same charges, similar charge, right? Got it, everyone?
Yes, sir.
Okay. So this is the basic, or you can say the simplest explanation about the similar and the opposite charges. Second point is like charges, no, sorry, opposite charges attract each other. So let me tell you how. Suppose again a positive charge is there, right? Right, and here a negative charge will be there. Let me this C square is different, which is negative, and the field and for the field of negative charge is towards the charge, like, and just like the opposite charge is away from the charge, but the field of the negative charge is towards the charge. Okay, like, okay. So as you can see, this one is towards the charge. Is it clear? Okay. So as you can see this thing, that this charge is saying that this charge is electric field is saying that okay, please move in the right side direction. And it means, and when it will basically move towards it like this, when it will move to, when it will move towards it like this, so as you can see, this charge is the direction of the fields are in same direction. Yes or no? This parallel one, this one, they are in same direction. I'm just telling you with the one line arrow. Okay, so it means that it is accepting it like this. Okay, the negative charge will say yes, please come in my side. Okay, so this is how the opposite and the similar charges work. That's why the similar charges repel, and that's why the opposite charges attract. Is this clear to all of you? Please do let me know. So this is the simplest and visualization of the concept. Any doubt so far to anyone?
Sir,
Yes, Maha.
sir, is the magnetic field of the electron really like that? Like the arrows going that way? Or is it just something you
Basically,
think?
it's an imaginary thing. Basically, the this electric field is an imaginary thing. These are imaginary lines. So because basically due to like after some take experiment, doing some experiment and all, that's how we basically draw these lines. Right. So you will understand the depth in the 12th standard, but right now, if I basically go in the depth, now you won't be able to understand that much in a like in an efficient manner. Right. So that's why this is the simplest thing. Okay. But these lines are drawn by the experiment. These are not just like these are imaginary, but imagination comes from the experiment. Like what is the direction of? They are outward, perpendicularly out. Clear? Okay. Chalo, that's great. So okay, so this is how the opposite charge repel, attract, and the similar charges repel each other. Am I clear to all of you?
Yes.
Yes,
Any
sir.
doubt to part to anyone? Sure. Last property is electric charge is quantized. Okay, quantized word is a little bit, you can say, very tough word in terms of science, right? But in the simplest manner, you can see this thing. Suppose quantized means small packet, means that charge is in a like charge is quantized means that it is in a discrete packet, like small packets with a definite number. Here, definite number. It means that it is not in fraction, it is not in negative, it is a proper natural number, you can say term. Okay? So I'll tell you just a second with the
So
formula.
a whole number.
Whole number, yeah. So Q is equal to NE. So this is the formula for the quantization of charge. Clear everyone?
So are we gonna use this formula?
We are going to use this one. Okay. And this N is the integral multiple. Basically, it starts from 0 to It starts from 0 and it goes until whatever is the last number. So it like this. So 3 dots means that it's going till infinity. Okay? And out so far to anyone?
So quantizer is basically the product of a whole number and
And the
electric
charge.
charge.
Yes, electric charge. It means that it tells you that there's a fixed charge, not in fraction. It's a complete integral. Like it means that if I'm saying that how many electrons are there, the electrons number of electrons will be in in a natural number. It will not be in the negative. It will not be in fraction. It will be an integral, or if it's a natural number. Okay. It means that if there is a zero, if n the value of n is 0, it means that charge is 0. If the value of n is 1, it means that 1, right? Okay. And the SI unit, just let me write it over here. SI unit of charge is coulomb. That is C. Okay. Okay. So charge can only exist in the number, in the integral number. Okay. Any doubt to anyone, please do let me know. Okay.
So coulomb is the SI unit of both the positive and negative charges.
Yeah. Basically, negative charge and positive charge is just the sign, is just the characteristic. But the amount of charge on a electron and proton is same. It only just the difference of sign. It's positive and it's okay. And let's say these are some things that you should understand and should memorize, because sometimes in the exam it's not given. So it's by default that a student should know this, right? So one electron charge on one electron is equals to minus 1.6 into 10 to the power minus 19 coulomb. Okay. So this is the charge on one electron, and this is, and charge for one proton is same, but the difference is of sign. Charge on one that is equals to 1.6 19 coulomb. Is this clear to all of you? Please do let me know. And let me tell you about the mass of electron as well as proton. There is, so mass of electron is different and mass of proton is different. So mass of electron is, so electron is a smaller, is a very lighter quantity. So mass of electron is equals to 9.1 into 10 to the power minus 31 A. And mass of proton is 1.67 into minus 27 kg. Clear? Any doubt so far to anyone? Please do let me know, everyone. Is there anyone who is having doubt? Maha, Harshit, Galvin, Gianna, Aya. Clear
No,
answer
sir.
सबको? ठीक है? So quantization means it's the integral. It cannot basically exist as a fraction. It will be complete whole unit. ठीक है? Now let's basically implement one thing, like how to implement this formula, and this is a one marker question in your exam. That this is a very, can say, commonly asked question in the exam. And these are the things that should be on your fingertips. Okay. So let me paste it. As you can see, it is written that it's an NCERT book question. It means that there is a very high possibility that this question might come in your exam, right? As a one marker, as a two marker, not a one marker, as a two marker. Or as it could come in your exam as the MCQ, and it will like ask you that what is the number of electrons present in one coulomb of charge. Okay. So as you can see that it is asking that how many number of electrons are there in one coulomb of charge. So Q is equals to 1 coulomb, right? E will be equals to 1 point. In this, we are not considering the sign because we just need to calculate the number of electrons. So we can basically ignore the sign of the electron. So that is the value of this 1.6 into 10 to the power minus 19 coulomb. Clear, everyone? Now let's implement the formula, that is Q is equals to Ne. Okay. So Q will be, Q is 1 is equals to N into 1.6 into 10 to the power minus 19 coulomb. So as you can see, we need to calculate the N. So we will shift 1.6 term on the left hand side. So that would be 1.6 into 10 to the power minus 19 coulomb. Right? They are just okay.
Sir,
Yes, Maha.
why do you take Q equals 1 coulomb? Shouldn't it be coulomb equals 1?
I didn't get your word. Maha, could you please repeat?
So why did you write Q equals 1 coulomb? Won't it be like coulomb equals 1?
No, no, no. Yeah, sorry, Maha. Question is saying that coulomb, 1 coulomb of charge. Charge is denoted by Q, and 1 coulomb is the quantity that is given. Now C is the, just like now we use the kg to represent mass. So kg is the SI unit. So coulomb is the SI unit of charge. Got it? And it is denoted by Q. So now, as you can see that 10 to the power 19 can be like basically will go in the numerator and it will become positive 10 to the power 19 divided by 1.6. So this 1.6 basically it will get, uh, if I remove the decimal, so that would be 10 by 16 into 10 to the power 19. Okay. So if you basically divide this thing, so it will come 0.625 into 10 to the power 19. So if I take 110 from here, so it would be 6.25 into 10 to the power 18 number of electrons are there in 1 coulomb of charge. It means that if you basically remove this decimal as well, so it would be 16, 625 and 25. So it will be 16 and 7, 9. Then 3, 3, 3, 3. These are the like this is the number which is present in the 1 coulomb of charge. Is it countable? See this thing that coulomb is a very big unit, right? So as you can see this thing that how like it is not countable itself. It is in million, in single coulomb of charge. Clear, everyone? Okay. So that's why it is. So now, the 6 point. So you have to remember this number. In 1 coulomb of charge, 6.25 into 10 to the power 18. Or if you remove this decimal in the questions, this is a possibility that they will remove the decimal. So that would be 625 into 10 to the power 16 coulomb. Oh, sorry, 16 number of electrons. Okay. So they can basically use this expression like this. They can use this expression like this, or they can use this expression like 625 into 10 to the power 16. It depends on totally on this. Am I clear to all of you? It means that 1 coulomb of charge is equal to the charge possessed by the 6.25 into 10 to the power number of electrons. Okay? So let me write it here. 1 coulomb is equivalent the charge contained in 6.25 into 10 to the power 18 electrons. Clear, everyone? It means that if you combine it 6.25 into 10 to the power 18 electrons, then you will get the charge as 1 coulomb. Any doubt so far to anyone? Please will let me know fast.
Sir?
Yes, Maha.
So over there, when you substituted the values over there you wrote 1 equals n, n into 1.6 into 10 raised to minus 19. Then C you wrote, right? But
Okay,
in
okay. That's a mistake. Sorry. Yeah, that
oh,
was
okay.
I had it mistake. I don't. Okay, sure. Okay, now. So now let's talk about this thing. That is the next topic. That is not that next topic in the sense it's the basically the some part of this topic. Okay, that is the conductors and insulators. Right. Just let me see whether taking it separately. Take it separately. Conductors and insulators. So let's talk about conductors and insulator terms. Right. So these are the you can say materials that we use okay, in the electricity as well as heat. So but right now we are studying electricity, so we will be discussing in context of electricity only. Okay. So conductors are those materials which allows the electric charges to flow in the conductor, in the basically material. It allows the electricity to flow without any resistance. Those are conductors. Insulators are those materials which do not allow the electric current to flow in it. So insulators basically is like wood, rubber, plastic, and many more items like what you can say wood item, plastic, and more one or two. I don't know. Like I'm not able to recall them. So these are the major you can say insulators like wood, plastic, rubber, right? And next conductor means they can easily basically allow the electricity to flow like metals, graphite. So graphite is a non-metal. Graphite is a non-metal. Most of the basically non-metal lies inside the insulator, but graphite is the only non-metal that basically conducts electricity. So you will study this thing in the carbonated compound chapter, right? So because of the layer structure of this
We already did.
yes, Maha. Okay. So basically, this gravity, I think you must have studied this in like, have you completed the carbon compound chapter? No, no. So when you study the 10th class chapter, 4th chapter, carbon and its compound, you will study this thing that graphite has a layer structure. Because graphite is a carbon allotrope, is an allotrope of carbon. So due to the layer structure, electricity can flow through it. But other than that, there is no non-metal that conducts electricity or that allows the electricity to flow through it. Okay. So now let's talk about the conductors part. So conductors is substances allow electric current to voltage ठीक है are called B part is basically metals are the good met- metals in metals like iron, aluminum, zinc, copper. In basically in the normal household wires, copper is used, right? So copper is used as the conductor, right? So when you will basically when an electrician works in your home, so you might so when he'll be working, you can basically observe this thing that there is a brownish type metal is basically present in the wires. So that metal is copper. Okay. Next thing is let me basically paste a picture so that you can understand. This is how. So basically, a plastic covering is there in the on the wire. So basically, if you basically remove that plastic covering, these are the very small, very thin wires present in it. So these are copper wires, conductors. Okay, plastic insulator is just used to basically so that they cannot touch each other. We will basically discuss short circuiting, overloading in the later part of this chapter. Okay, and I think the magnetic effect in the magnetic effect. Next one is plastic case. So just see this thing. These are the metal pins that is used, right? So that's why metal is the best conductor of electricity, right? It is the best right now we use in our day-to-day life. Clear, everyone? Next one is insulator. So basically, insulator is used to basically protect the metal. Is used to just like it's due to heat, weather, or water. The insulator work is there in the wire. Yeah, insulator that is A. Allows the current flow are called insulators. Okay. The examples of the insulators are non-metal, are good insulators. Clear, everyone?
Yes, sir.
Any doubts so far, 21? Okay. So after this class, there will be an assessment based on the electric charges. Please do the electric charges assessment. Okay. After leaving the class. Is this clear to all of you? Please do let me know.
Yes, sir.
Chalo, that's great. Actually, can anybody tell me that what is the reason of what is the reason behind the electricity flow? Is there any, which is the thing which thing is responsible for the flow of electricity in the conductor? Which which quantity, which thing, or which effect, or something like that? Whatever is in your mind. Have you ever observed this thing? Have you ever gave the attention on it? Tell me, everyone.
Sir, can you repeat it louder?
I'm saying that what is the reason behind the flow of electricity in the conductor?
So basically, I think there are E minus electrons which help to flow the current.
E minus electron, Harshit? I didn't
Negative,
get. Acha, negative.
negative electron.
If you're saying electrons, so by default it would be negative. So you don't need to say no need to say that negative electron. So if you're saying that electron, so it's already by default negative. Okay. So it means that you are saying that. Could you please repeat again that term, Harshit?
Like that, there are negative electrons in current which help them to flow the current.
Achhi. Anyone else? Maha, Jana, Ayan, Yalu. Acha, please tell me. Like I know that Galvin told me that he has some network issue. Except Maha, nobody is basically there with the video. I didn't know that. Why do you switch off your videos in the middle of the class? If I cannot see you, how would I be able to know that whether you are attentive in the class or not, whether you are basically understanding my explanation or not? The only way to communicate is the video, and you are switching off the video without telling me even. If you have any network issue, you can tell me in that. Galvin has told me this in the start of the class, so I like that is acceptable, no issues. If you have any network issue, but without any information and without any issue, you're switching off your camera, and I won't be able to interact with you. It's like a blindfolded thing. Like I cannot see you. So if you are there in the class, so at least just for 1 hour, you can switch on your videos, everyone. I don't know that if you're sitting in a class, so you must be attentive now. See, this is a class, very small class, only 1 hour. So I hope that you are trying to get my point, what I'm trying to say. This is a virtual class, I am not present physically right there. So only way to communicate is the video. If you have any issue, if there's some background thing or something like that, you can tell me in the chat. That is acceptable. I will not basically force you to switch on your video. But if there is nothing and still you are switching off your video, so that is not acceptable, and that is not the part of the class. Okay? So I hope before requesting in the start of the class, you can switch on your video without recalling. Okay? Chalo, next thing. Okay, non-metals. I was just asking. Okay. So basically, the reason is that free electrons present in the conductor basically are responsible for the flow of current. So in the ninth class, there was a term called valence electrons, valency. Do you know this thing that metals have the basically valence electron, like loosely bounded electrons. So those loosely bounded electrons are responsible for the flow of current, for the electric, for the production of, right? So when they will flow, the electricity is generated by the flow of the electric charge, the free electron, not the bounded one. So in that, like in the aluminum, free electrons are there, Al plus free. In the sodium, it is one electron that is free, Na plus. In the magnesium, it is Mg plus two. In the, you can say, okay, and in the potassium, that is one electron is free, right? So 2887. 2881. Last shell has one electron. And calcium has two. So those free electrons, the bounded electrons are not responsible for the flow of current. The loosely bounded electrons, which can basically leave the shell. Those electrons are responsible for the generation and for the production of current. Am I clear to all of you? Harshit, Galvin, Gianna, Maha?
Yes, sir.
Yeah.
Yes, sir.
Okay. Okay. So let me tell you. Uh, Presence of free electrons. So if a material is having the free electrons, then it can only be considered as a conductor. Okay? In a material or substance, so if there is no basically free electrons present, so there won't be any, you can say, so that will not be considered as a conductor. Okay, everyone?
Okay, sir.
So that's great. Any doubt so far to anyone? Please do let me know. Please do let me know, everyone, if you have any doubt.
No, sir.
Okay. So these are the basics about the electricity chapter based on the electric charge. So basically, if there are no free electrons, that material will not be considered as a conductor and electricity cannot flow through it. Clear? Because ultimately, electricity is the flow of charge. When the charge will flow, electric current is produced, right? And and basically, we have two types of electric current basically. One is static electricity, another one is a dynamic electricity. Static means suppose that you have a ball and basically a balloon and a glass, or basically a glass rod and a
Oh,
woolen
excuse
rod.
me, sir.
Yes, Harshit.
Sorry to disturb, sir. Sir, actually,
Uh-huh.
I have to leave somewhere urgently. So can you leave the class?
Okay, so you can leave, Harshit.
Okay. Okay. Thank you.
Oh, welcome. Okay, so basically, static electricity means that when you have two opposite, basically, when you have suppose that glass rod and a woolen rod, when you rub it, so basically there is a charge produced on both the material. One of the material it could be positive charge, excess charge is basically positive on the one material, and another Negative charge, it means that some charge is transferred to that material which is being positive. So that type of electricity is called static electricity, right? Suppose when we rub our palm in the when we rub the palm in the, suppose that in the head, I think so. I'm not sure about the just a second, let me check. It's the hair one or something else. When the comb is rubbed with the dry hair, na, and you will basically take that comb, uh, that comb will have some electric charges, and basically you can use you can also observe this thing. So when you will take the electric comb right next to your arms here, so they will basically get electric charge. They will basically go they will become straight 90-degree perpendicular to the skin. So that is the type of static electricity. Right? Dynamic electricity means that electric charge is flowing through the conductor. It means that in this chapter, we are going to study the dynamic electricity, dynamic electric current. Right? Basically, charge is flowing through the conductor. We are not going to study about the static one. We are just going to study the dynamic. Okay? Clear, everyone?
Yes, sir.
Yes, sir.
So that's great. Just a second. So next class is going to be very important, everyone. Why did I ask that? Because in the next class, we are going to study the electric potential as well as potential difference. And this is the most important fundamental topic to understand. Because if you do not understand what is potential difference, what is electric potential, and what is the significance of this quantity, you won't be able to understand the further concept. Because this is the quantity that is basically responsible for the flow of charge, for the flow of electric current from one point to another point, potential difference. And both are complete, like electric potential and potential difference are very similar to each other, but there is a small minor difference. Electric potential is not applicable in the real world, but potential difference is the real life application. Okay? Just a second, let me
Okay, sir.
check. So after this class, you have to go and check out the assessment. Let me check if there are any type of questions that we can do. And numericals, basic numericals are there, the topic of electric potential as well as electric current. And from the Ohm's law onwards, the chapter will be a little bit difficult when we'll start the combination of resistors, series and parallel. We'll do the Joule's law of heating, right? When we will do the power, these, and we'll also discuss how to calculate the electricity bill that you basically use in our normal household. Okay. So I'll be sharing some questions to all of you. So you have to go and check out those questions as well, assignment questions. Okay. So, Gianna, you have school exam on 10th of October now of math.
Yes, sir.
Okay. Electricity is also coming in your school exam, 21st.
Sorry, sir.
Electricity chapter is coming in the school.
No, sir.
No, but the syllabus that you have shared with the on the official number mentions that electricity is there half yearly. Please check. So if that is the case, so you should have informed me earlier that electricity is there, so that I can schedule your extra classes for the exam. Like whole electricity chapter is coming, or some portion of electricity is coming, like Ohm's law?
Sir, only a portion.
Which portion? Could you please tell me? Maha, are you sure that 2 chapters are coming for you?
Yes, sir.
Sure, that's great. Okay, so how's the preparation? It seems like you'll be completely prepared for the exam.
Not really completely prepared. Like I have started my revision
Sure, that's great.
to practice more.
What about you, Gianna? Are you completely
Sir,
prepared?
sir, I'm not completely prepared.
Okay, so no issue. But the thing is that keep revising. Okay, please let me know whether which portion is coming in the electricity. Like till
Sir,
Ohm's law,
only till 11.5.
11.5. Could you please tell me the topic number? Topic name, sorry.
11.5 factors on which the resistance of conductor depends.
Okay, ठीक.
Till
Okay,
there.
that okay. It means that Ohm's law and the factors affecting resistance. Resistivity is also there.
Sorry, sir.
Resistivity is also there or not? Resistivity.
Sir, yeah, I think I'll just get back to you about that.
Okay, please ask from your school teacher that whether you have resistivity in your syllabus or not in the
Yes, sir.
midterm. Okay? And
Yeah.
basically, if I'll try to complete that portion till 21st. If not, I'll schedule some extra class, 1 or 2